For Unit 6, Objective 7, we're going to start looking at the graphs of square roots and cube roots. The square root graph is Objective 7. So like all the other graphings we've done, we're going to start off with the parent function. And the parent function is y equals the square root of x. Or in function notation, it's f of x equals square root x. Now, we've said all along in this unit that as long as we keep our answers to real numbers and we don't go down into imaginary numbers, the lowest number we can square root is the number 0. If we try to square root a negative number, we need the imaginary number I to help us. So we're going to stay away from that. So you can see the values of x that I've chosen. The lowest one is 0 because 0 is the smallest number that you can square root and stay within the domain of real numbers. So when x is 0, y would also be 0 because the square root of 0 is 0. Now, notice the x's that I chose to help us complete the table. I didn't just choose those numbers randomly. There's a reason for those numbers. They are squares. So if x equals 1, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Now the logical next one that I would choose if I wanted to keep going would be 25. When x equals 25, the value of y would be the square root of 25 because that's the function, and the answer would be 5. Now that I have quite a few points that I can plug into the graph, I can show you what the graph actually looks like. So 0, 0, remember every graph we've studied this entire year in its parent function has had either a vertex or a very important point. Well, for the square root x graph, the very important point is again at the origin 0, 0. Now look what the other numbers would be. When x equals 1, y equals 1. When x equals 4, y equals 2. When x equals 9, y equals 3. When x equals 16, y equals 4, and it just goes on and on and on and on. Now, let me try to connect these correctly to get a pretty good idea of what's going on with this graph. That's not bad. So that's a pretty good representation right there of what y equals square root x looks like. If I'd have graphed the next one, 25, it would have been way over here, and then 5 would have been a little bit higher than 4. So you can see it continues to go up, but the rate at which it continues to climb gets slower and slower and slower. It never levels out. It never becomes a straight line. And if it never becomes a straight line, then it never turns itself back and turns down. So if we look at a few things about this graph, for instance, its domain. Remember, domain, the value of x's. So as far as the domain is concerned, the values of x start at 0, just like our table started at 0. So 0, and then positive infinity. It just goes to the right forever and ever and ever. Now the range are y's. Now look at this graph from the y viewpoint. The lowest value again is 0. And like I told you, the graph continues to rise, but just at a slower and slower pace, but it never levels out. So the fact that it continues to rise would mean the top end of this graph would also be infinity. Now the open interval of x, where x is increasing, once again, this is always increasing. It just gets slower and slower and slower. The rate at which it increases get smaller and smaller and smaller, but it does continue to increase. So the open interval where x is increasing is from 0 to positive infinity. Now, the average rate of change. The last thing we need to worry about on this graph is the average rate of change. Now, this is a curve. So when we talk about the average rate of change, what we're really doing is we're talking about what is the average slope between whatever values of x are being asked. So between x equals 1, which would be right here, this is 1, 1, and x equals 9, that would be right here, this one I believe. 0, 1, 2, 3. Yep. What is, even though there's a curve that joins these 2 points, if we made a straight line between those 2 points, what would be the average rate of change, or what would be the slope? So really, that's all it is. It's a slope. And the 2 points we're using are, go back up to the table, when x is 1, y is 1. So we're using 1, 1 as one of the points. And when x is 9, y is 3. So we're using 9, 3 as the other point. So what we're really doing is we're simply finding the slope between these 2 points. So y2 minus y1 over x2 minus x1. So 3 minus 1 over 9 minus 1. Subtract your y's, then subtract your x's, and make sure you go in the same direction. So 3 minus 1 is 2, 9 minus 1 is 8. So 2 over 8 equals 1 over 4. So that would be the rate of change for this problem. For the next example, we have a more involved function, but it's still a square root function, so we know what its basic shape is going to look like. Now, if we go straight to the rules of shifting, we're going to use the exact same rules that we've used throughout this entire course for every single function we've studied. Since x is being immediately added by 3, so this plus 3 is attached to the x. We know this is the opposite part of the shift. So x plus 3 means we're going to go left 3. But then the ending part of the function goes plus 4. So that's the same part of the function. Remember, this is the opposite. When it's attached to the x, it's always opposite. When it's not directly attached to the x, it's the same. So the shift for this function is left 3, up 4. Now the next thing we have to do is figure out left 3, up 4 from what? Remember, the very important point in a square root graph is 0, 0, the origin. So that's where the square root function would begin if it hadn't been shifted, but it has been shifted. So I'm not going to put a point there, but that is going to be my starting point. I'm going to go left 3, and I'm going to go up 4, and that is the starting point of this square root graph. And we know what it looks like. It just goes like that. I'm almost running out of room up there. But that's what it looks like. Now, if we want to put in some actual values, that's almost as easy because we know the lowest number we can take the square root of is the square root of 0. So we have to ask what value of x would produce square root 0. What would x have to be in order for this to be equal to 0? And that's negative 3. So negative 3 plus 3 is 0. The square root of 0 is 0, and then plus 4 is 4. So either way, whether we do it with points or whether we do it with shifting, what we figured out was the beginning of this graph is at negative 3, 4. Now, if I want to know some other points, once I've figured out the square root of 0, then the next number that is a perfect square is 1. So what value of x would make 1 in here? And that would be x equals negative 2. So when x equals negative 2 plus 3 is 1. The square root of 1 is 1, plus 4 is 5. Now, the next perfect square after 1 is 4. So what value of x would I have to put in right there in order for this to be the square root of 4? And the answer is 1. 1 plus 3 is 4. The square root of 4 is 2. And then 2 plus 4 is 6. After the number 4 is the number 9. That's the next perfect square. So what value of x would get me to have a 9 on the inside of this square root? And that would be x equals 6. So if I plugged in a 6 right there, 6 plus 3 is 9. The square root of 9 is 3, plus 4 is 7. Now, if we wanted to go one more, we've done square root 9, so the next perfect square is 16. So I would need an x value of 13. 13 plus 3 is 16. The square root of 16 is 4, and then 4 plus 4 is 8. So there are the first 1, 2, 3, 4, 5. There are the first 5 lattice points in this graph. I could plug in any number I want, like right here. I could plug in 10 if I want, but look what would happen if I did. 10 plus 3 is 13. I don't know what the square root of 13 is. It isn't a nice integer rational number. I could get the calculator out, but I don't want to. I want to work with nice rational integers, and that's why I chose these numbers. So if I were to plug these points, if I were to plot these points into this graph, if I had a more detailed graph, I would still get a graph that looks like this. So now I can answer some questions about domain and range. Remember, domain is x. So what is the domain of this graph? Well, the x values start at negative 3. And they go on to the right forever. What's the range? Range is y. So the y values start at positive 4. And they go up forever. Now here's something we haven't looked at. X-intercept. What's the x-intercept of this graph? Well, just by looking at it, we know there is no x-intercept. This graph is never, ever going to cross the x-axis. So I'm going to put does not exist. Or DNE. But the next question would be, well, what's the y-intercept? The first thing I would look for is, does it even cross the y-axis? And sure enough, it does. It crosses the y-axis right here. I just need to figure out where that is. And algebraically, the way you find the y-intercept is you set x equal to 0. So that's what I'm going to do. I'm going to go in back up to this function, and I'm going to set x equal to 0. So y equals the square root of, now I'm just going to replace x for 0, 0 plus 3, and then add 4. Now here's where my calculator is going to come in, because y equals the square root of 0 plus 3 is 3 plus 4. Off the top of my head, I have no idea what the square root of 3 is. So I'm going to have to figure that out. Go onto your calculator, take the square root of 3, and you get approximately 1.7. Y equals approximately 1.7 plus 4. So y is approximately 5.7. So if you look back up on our little sketch right here, we've just figured out that this point right here, where the graph crosses the y-axis, is approximately at 5.7. So it would be 0, 5.7. Now the last part of this question would be, what's the average rate of change for x as x changes from 13 to 97? Well, I don't even have that on my graph. Actually, I do have the point for 13, if you look at the table. So when x equals 13, when I plug in 13 into the function, I get 8 as the answer. We know that. But what do I get when I plug in 97? Well, the square root of 97 plus 3, and then plus 4. 97 plus 3 is 100. That's the square root of 100 plus 4. The square root of 100 is 10 plus 4 is 14. So, at this end, when x equals 13, y equals 8, because I just plugged in. At this end, when x equals 97, y equals 14. So I know my other point, 97, 14. So now to find average rate of change, it's nothing but slope. So let's go this y minus that y, 14 minus 8 over 97 minus 13. So 14 minus 8 is 6. 97 minus 13 is 84. Both of those numbers are even, so I can definitely reduce them by a factor of 2. So that would be 3 over 42. Now, both of those numbers are divisible by 3, so I can reduce them further by a factor of 3. So 3 into 3 goes 1, and 42 divided by 3 is 14. So that's the average rate of change from x equals 13 to x equals 97. For this last example, I'm not even going to make a table of values. I'm going to show you how you really don't have to. So I have f of x equals 4 minus the square root of x minus 2. So the first thing I would do is I would rearrange this to where the square root part comes first, and then the 4 is the last part of the equation. So that would simply be f of x equals negative square root x minus 2, and then plus 4. Now the next thing I do is I would look at the shifts. The x minus 2 means there's going to be a shift of 2 units to the right. Because remember, this part's the opposite part, and this part is the same part. So 2 units to the right and 4 units up. That would be the shift. And my starting point is actually 0, 0, the origin. So I'm going to do exactly what these instructions tell me to do. I'm going to go 2 units to the right and 4 units up. And that's going to be the starting point of this square root graph at 2, 4. Positive 2, 2 units to the right, and 4 units up. So 2, 4 is the starting point of this graph. Now, you might notice there's a negative in front of this square root. So instead of the graph going up like our previous ones have, this one's actually going to come down. So it's going to look something like that. That's a really good representation of this function right here. Now, let's look at the domain. Okay, the values of x. The domain begins, the x values begin at 2, and they go on forever to the right. So that would be infinity. Now the range, the y values. Actually 4 is the highest y value that this graph achieves. So it actually has a peak, but it goes down forever and ever and ever. So I'm going to start my notation with negative infinity, and I'm going to end it at positive 4, because positive 4 is the highest value of y that this graph achieves. Now, let's look at the x-intercept. Just by looking at the graph, we do know there is an x-intercept. It's right there. So we want to figure out what is that point right there. What is the x-intercept? And we always find an x-intercept by setting y equal to 0. So that's what I'm going to do. I'm going to come back to the original equation. Well, I'm going to come back to this one right here. And this is the y, so I'm going to set it equal to 0. So 0 equals negative square root x minus 2 plus 4. And now I'm just going to solve this algebraically. First thing I'm going to do, I'm going to move this plus 4 over to the other side by subtracting 4. So negative 4 equals negative square root x minus 2. Now I'm going to get rid of this outside negative right here by dividing both sides by negative 1. And that's going to give me positive 4 equals square root of x minus 2. Now, the next thing I'm going to do is I'm going to square both sides. So if I square this side, I get 16. If I square that side, I simply get x minus 2. The way to get rid of that radical is to square both sides. And now all I have to do to solve for x is add 2. So 18 equals x. And there's my answer. My x-intercept is at, when x equals 18, if you look all the way back up to the graph, that x value right there is 18. The x-intercept is 18, 0. Now, what about the y-intercept? Well, look at the graph. The graph never crosses the y-axis. So mathematically and graphically, there is no y-intercept. The y-intercept does not exist. Now, what about the average rate of change between the x values of 3 and 66? Well, remember at the beginning of this problem, I told you I'm not going to make a table of values to figure out what the graph looks like, because I have a pretty good idea of what the graph looks like right here when I did this. But in order to find an average rate of change, I do have to find a couple of points. So I'm going to plug in 3 when x equals 3. Let's figure out what y equals. 3 minus 2 is 1. The square root of 1 is 1, and 4 minus 1 is 3. So y is also 3. But what happens when x equals 66? Plug in x equals 66 right here. 66 minus 2 is 64. The square root of 64 is 8. And 4 minus 8 is negative 4. So you did have to find a couple of points. And here they are. Now it's time to do slope. So this y minus that y, negative 4 minus 3 over this x minus that x, 66 minus 3. So I get negative 4 minus 3, which is negative 7, over 66 minus 3, which is 63, which, when you reduce that down, is negative 1/9 as your slope. And that makes total sense because if you go back and look at the original graph is going down because of the negative, not up. So the average rate of change between an x value of 3 and an x value of 66 is negative 1/9. So for my last wrap-up problem, I thought I'd give you something just to do very quickly. And if you can do this real quickly, it means you really do understand what's going on without having to go through all the individual steps. If you were asked to sketch this graph, well, we know the translations or the shifts. The shift in this equation is left 5 and down 8. So left 5, opposite of this, same as that. So that tells us if we started at 0, 0, and we went left 5 and down 8, this would be the beginning of the graph at negative 5, negative 8. And we know what a square root graph looks like. It looks something like that. It's a positive square root. Now, there isn't a negative in front of it, so that's what the graph would resemble. Now, let's talk about the intercepts. Does it have an x-intercept? Yes, it does, right there. Does it have a y-intercept? Does it cross the y-axis? Yes, it does. It crosses the y-axis right there. So let's focus on those two intercepts. Let's find those two intercepts. So I'm going to drop down, and I recreated the function right there so we don't have to keep looking for it again. Remember, to find the x-intercept, you set y equal to 0. So 0 equals the square root of x plus 5 minus 8. So to solve for this, add 8 to each side. So 8 equals the square root of x plus 5. Square both sides, and you get 64 equals x plus 5. Now, subtract 5 from each side, and you get x equals 59. So that's the x-intercept. The x-intercept happens at 59, 0. When x is 59, y is 0. So that's the x-intercept. Now, the y-intercept. In order to find the y-intercept, you set x equal to 0. So y would equal the square root of set x equal to 0, so that would be 0 plus 5 minus 8. So y equals the square root of 5 minus 8. So y equals, now here's where I got to jump on my calculator because 5 isn't a perfect square. So if I take the square root of 5, I get approximately 2.2. And if I take that 2.2 and I subtract 8, I get negative 5.8. So y is approximately 5.8. And that makes, oh, it's negative. And that makes the y-intercept when x equals 0 approximately negative 5.8. So now I've found the two intercepts, and we knew all along, the minute we graphed this graph, we knew that there was a y-intercept, and we knew there was an x-intercept. So all we had to do was find it, and we did, and hopefully you have a really good understanding of graphing square roots.